Please welcome Dr. Waiser.
It's really nice for me to be able to talk to you about my research on Wascana Creek. I was one of those scientists that wasn't quite allowed to speak about my research, and I always felt that you paid my salary, so you deserve to know what it is I do. I'm going to outline the problem first, and then I'm going to talk about Wascana Creek and why we need to pay attention to this sewage treatment plant and why there is the need for this upgrade. We are able to detect low concentrations of pharmaceuticals and personal care products in treated sewage effluent. Things like antibiotics, the active ingredient in birth control pills, insect repellents, caffeine is a great social marker of civilization, and it's also found in treated sewage effluent. So all of the drugs that we ingest, we only absorb about 20%, so the 80% is excreted. And our sewage treatment plants are not designed to remove these substances. With the advent of these increasingly sensitive detection methods, we are able to detect these pharmaceuticals and personal care products in receiving water bodies worldwide. Even the antibacterial soap that you use, there's an ingredient called triclosan, which is it's a bactericide, and it is present in soaps and toothpaste. This is getting into our aquatic ecosystems. Modern sewage treatment plants are not designed to remove these substances, and indeed, the removal of these may be a few years off. Why should we be concerned about this, the presence of these substances in our waters? Well, most of these are designed to interact with a biological target. And lots of times these targets are shared not only with humans, but with animals as well, and indeed some kinds of aquatic organisms like fish. And most act at very low concentrations, so they're designed to act at low concentrations. So for example, a Canadian study in 2007 at the Experimental Lakes area, which you may have heard that the Harper government wanted to close down, and this was done by Karen Kidd, who is a professor at the University of New Brunswick. What she did in one of these experimental lakes was she added ethynyl estradiol to the water at a concentration present in treated sewage effluent. What happened was that over a period of 2 years, all of the male fish became female, and so the population crashed. This is why, part of the reason why we should be concerned. Most pharmaceuticals are also designed to resist degradation, and although the concentrations are low in aquatic ecosystems, they're constantly present. Chronic exposure of bacteria to antibiotics does lead to antibiotic resistance. Worldwide, sewage treatment plants also add significant concentrations of all forms of nitrogen and phosphorus to receiving water bodies. And we do know that phosphorus is a major limiting nutrient for algae. So let's get around to talking about Wascana Creek. We've got a population of about 200,000, and as we know, the sewage treatment plant is on Wascana Creek. Now, the important thing about Wascana Creek is its hydrology. We want to talk about climate and hydrology together here. So climate, we live in a semi-arid ecosystem where evaporation exceeds precipitation. This puts significant pressure on water bodies. With respect to Wascana Creek, most of the flow in the creek is from spring melt. So we have a big peak in the spring and then base flow thereafter. And so at certain times of the year, treated sewage effluent makes up almost 100% of the stream flow. So when the city of Regina talks about sewage, it's not drinking water. This treated wastewater becomes a part of the aquatic ecosystem. It becomes a part of Wascana Creek, which flows into the Capel, which flows into the Capel Lakes. So that argument really doesn't hold water. We need to be concerned about treated sewage effluent because it gets back into our aquatic ecosystems. The treated sewage effluent coming in has certain concentrations of nitrogen, phosphorus, and pharmaceuticals, and they're not really diluted. The old adage, the solution to pollution is dilution. Well, for most of the year, this does not occur in Wascana Creek. The problem, and this is why you need a new sewage treatment plant, it is an effluent-dominated system, so low base flow. Most of the flow is treated sewage effluent, and we see massive increases in all forms of nitrogen and phosphorus directly below the sewage treatment plants. And the concentrations of some forms of nitrogen, specifically unionized ammonia, which is very toxic to fish, concentrations in the creek are high enough to kill fish. Environment Canada scientists have worked a little bit on the creek and shown that there are not a great deal of fish for about 10 kilometers downstream of the sewage treatment plant. What we can say is the concentrations are high enough to kill creek biota, to change overall ecosystem functioning, and to render creek water unfit for drinking. Normally, creeks have the sediments in creeks, and the biota that live in the sediments have an ability to actually take up the nutrients and use them to grow. However, we can think about Wascana Creek as a glass of water to which you're adding more and more sugar. Eventually, it can't absorb anymore, and the sugar comes out of solution. Well, this is what's happened in Wascana Creek, that over long periods of time, seeing these high concentrations of nitrogen and phosphorus, that the creek's no longer able to absorb and to use those nutrients. And in actual fact, the sediments are probably going to be a source of phosphorus. And so the nitrogen and phosphorus do travel down into the downstream Capel system, and Dr. Peter Levitt here at the University of Regina has shown with stable isotope analysis, nitrogen coming from the sewage treatment plant has a specific signature which we in the lab can detect. And he's shown that the nitrogen originating from the sewage treatment plant is responsible for the 300% increase in production of the downstream Capel lakes. Not that the downstream Capel lakes haven't originally been enriched, they have, but the sewage treatment plant is just adding to this problem. Some of you have seen cyanobacterial blooms in Pasco Lake, and I just like to say everybody uses blue-green algae, but in actual fact, they're cyanobacteria. Every 10 years, the Watershed Authority puts out a state of the watershed. They were trying to gauge the health of the Wascana Creek watershed based on water quality, which is nutrients, and they didn't have enough information to actually say how stressed this watershed was based on nutrients, which I found quite unusual given the fact that this is a highly stressed ecosystem that has a sewage treatment plant on it. So there is a need for monitoring on this system. The surveys that I did from 2005 to 2007, we always detected PCPs, PPCPs in the water, and this is not unusual, this is worldwide. And it included antibiotics, really high concentrations of gemfibrozil, which is a lipid regulator, anti-inflammatories, insect repellents, etc. And they tended to be highest when the creek flow was the lowest. In 2005, we're still seeing antibiotics 104 kilometers downstream of the sewage treatment plant. What we do is we grow something called biofilm. It is made up of algae and bacteria, and they're all in this nice sort of slippery sugar matrix, an exopolysaccharide matrix, plus a lot of very single-celled protozoan grazers that feed on this biofilm. But this biofilm also forms the base of the food chain, and is fed on by aquatic insects, which are in turn fed on by fish. We can have a look at these biofilms that we grow, exposing them to various pharmaceuticals in the lab, and we can look at differences. Let's get to the conclusions. The Regina sewage treatment plant is responsible for the massive increases in nitrogen and phosphorus, then the degradation of downstream lake water quality. The sewage treatment plant is also responsible for a decline in the ability of the stream to actually absorb some of those nutrients. And the concentrations of certain forms of nitrogen are really high enough to kill creek biota. Creek organisms are chronically exposed to low concentrations of pharmaceuticals, and the exposures are greatest during the winter. And the effects experiments that we've done so far indicate that there may be some effects which may resonate higher in the food chain, perhaps to fish. So Wascana Creek is an ecosystem at risk, and the study outlines the need for the replacement of the Regina sewage treatment plant. What are the plans for monitoring this creek? So you can put a sewage treatment plant in that is going to, they say it's going to lower the concentrations of nitrogen and phosphorus getting into this system, but you need to make sure that this is so. The way that you do it is having a fairly good monitoring system in place. Not expensive to do, hasn't been done yet by the Saskatchewan Watershed Authority, and it's worth asking the question, what are the plans for monitoring once this new sewage treatment plant goes in? I just want to end again by saying that sewage, wastewater is water that becomes part of an aquatic ecosystem. You cannot separate the two. And with that, I'll end.